Chapter 4, Structure of the Atom. In chapter 3, we have learned that the atom and molecule are the fundamental building block of a matter, okay, which we have already studied. Okay, that atoms and molecule are said to be what? Okay, fundamental building block of a matter. Okay, there is a necessary of whom okay atoms and molecule for preparing a blocks of a matter. Okay, so atoms and molecule which we have already studied in chapter 3rd. Now in this chapter we will study the structure of particular different atoms and how it is formed. Okay, the existence of a different kind of a matter is due to the different atom. Okay, existence of a different kind of a matter is because of whom okay different atom consisting them. Okay, because of them they have a different type of existence in a natural. Now the question arises, what make the atoms of one element different from the atom of another element? Okay, how we can distinguish a different type of atoms of a one element to a atoms of another elements. Okay, we will study that only. And the second is, are atoms really individual? Are atoms really indivisible as proposed by the delta? Or are there are smaller constituent inside the atom? We shall find out the answer to this question in this chapter. Okay, in this chapter we will study that only. Okay, detail of atoms. We will learn about subatomic particle. Subatomic particle which are present in the atom. We will study that also as well as detail in a atom. In a atom, what is a differentiation thing or a matters which are present and differentiating them from other. Okay, we will study that only. The various models that have been proposed to explain how these particles are arranged within the atom. Okay, now we know that atoms, okay, in atoms there is a presence of lot of particle. Now if the particle are present, then how they are arranged, okay, we don't know. Okay, what is the proportion of a arrangement? Okay, so by performing different experiment, okay, many chemists as well as many scientists has given its conclusion. Okay, they have given its conclusion. We will study that only. Okay, and they have performed lot of experiment. Okay, and by through which they have given its justification as well as they have also given its conclusion. Okay, we will study that only. In this chapter we will study that how a different atom are present. Okay, in atom there is a presence of particle and that particle how it is present. Okay, arrangement of particles. A major challenge before the scientists at the end of 19th century was to reveal the structure of the atom. Was to reveal the structure of an atom as well as to explain its important properties. Okay, about its important property, okay, they have given its justification. The elucidation of a structure of an atom is based on the series of an experiment. Okay, depending on the experiment, they have given its elucidation of a structure, how the structure are there or exist in nature. Okay, all these experiments they have done, and at last they have concluded that this is the phenomena of a particle in the atoms. Okay, all these things we will study in this chapter. Now, one of the first indication that atoms are not indivisible. First is what? That atoms are not indivisible. Okay, atoms are not indivisible. Comes from the studying static electricity and condition under which electricity is conducted by the different substances. Okay, through which by applying electricity they have performed a certain experiment And through experiment, they have concluded that atoms are not indivisible because they are conducting electricity by a different substance. Some substance existed which are what, okay, conducting electricity from it, okay, through which they have given certain conclusion, okay, that some of the atoms are not indivisible, or most probably atoms are not indivisible. Okay, so they have performed a experiment, okay, by applying a different electricity through a substance, and some of the substance have easily pass electricity from its structure. So charge particle in matter. Now second question arises is certain charge will be there, okay, in a matter. For understanding the nature of charge particle in matter, let us carry out a following activity. Certain activity we will do, through which we will see that there is a presence of a charges in the atom. Can we conclude that rubbing two objects together, they become electrically charged? Okay. First, what we are doing, we are rubbing two objects together. Okay. When we are rubbing two substance or a object with each other, at that time we can see that electrically charged. Okay, they get electrically charged and electricity may be produced. But this is not a proper amount, okay, of electricity, but they are just what, okay, electrically charged. Okay, the object which we are rubbing, they get electrically charged. Where does this charge come from? Okay, now the question arises that where this charge come from. This question can be answered by knowing that an atom is divisible and consists of charged particle. Okay, atom can be divisible and they are consist of what? Okay, charged particle. In atoms you can see that there is a presence of a charge. Okay, so different amount of charge are present in an atom depending on its capacity. Many scientists contributed in revealing the presence of charged particle in an atom. Many scientists contributed in revealing the presence of charged particle in an atom. It was known by 1900 that the atom was not a simple. Atom is not a simple but indivisible particle, but containing at least one subatomic particle. Okay, in that we can see that there is a presence of what? Okay, atoms are not a simple; they are indivisible particle. Okay, they are indivisible particle, but contain a one subatomic particle, that is the electron. Okay, the electron. Okay, in atom you can see that there is a presence of electron identified by J.J. Thomson. Okay, who has identified? J.J. Thomson has identified electron. The electron identified by J.J. Thomson. Okay, so in atom we can see that electron will be present. Okay, so an electron is discovered or identified by whom? Okay, J.J. Thomson. Even before the electron was identified, E. Goldstein in 1886 discovered the presence of new radiation in a gas discharge and called them a canard ray. Okay, electron was before also identified by whom? Okay, E. Goldstein in 1886. When he is discovered, okay, 1886, discovered the presence of new radiation. Okay, he has discovered that new radiation are there in gas discharge. Okay, in a gas discharge and called them as a canard ray. The radiation which was exerting or radiating are said to be which ray? Okay, canard ray or canard radiation. This ray were positively charged radiation, or okay, the charged radiation which we are existing is what? Okay, positively charged radiation. They are existing which ray? Positively charged radiation, which ultimately lead to the discovery of another subatomic particle. okay, due to which a second subatomic particle has been discovered. This subatom particle has a charge equal in magnitude but opposite in the sign to that of an electron. Its mass was approximately 2000 times as that of an electron. Okay, so one by one they have discovered a different type of particles. Okay, first electron, when it was discovered by J.J. Thomson, it was before also discovered by whom? Okay, E. Goldstein in 1886. Okay, during the performing a presence of a new radiation in which gas stars are there, and they have told that radiation as a canard radiation or canard rays. Okay, these ray were positively charged. Okay, this ray was what? Okay, it was positively charged radiation, ultimately lead to the discovery of what? Okay, another subatomic particle. These subatomic particles are said to be what? Okay, these are said to be proton. How proton? Okay, its sign is opposite to the electron. Okay, if we take a sign of a electron negative, okay, the electron is negative in charge. Here proton will be what? Okay, it will be positive in charge. Okay, and it have a mass up to how much? Okay, 2000 times of a electron. It is how much? Approximately 2000 times than the electron. Its mass is 2000 times more than a electron. It was given a name as a proton. Okay, he is given as a proton. In general, an electron is represented as E minus. Okay, here you can see that electrons are mostly indicated by E minus. Okay, or a minus sign. Okay, so obvious that proton will be indicated by plus, P plus. Okay, here electron is E minus, so proton will be P plus. Okay, so from this we can say that proton have a plus charge, okay, which is P plus, and electron have a minus charge, which is E minus. Okay, the mass of a proton is taken as 1 unit. Okay, and its charge as a plus 1. Okay, the mass of an electron is considered to be negligible and its charge is minus 1. Okay, so mass of a proton which we are taking is taken as a 1 unit and its charge is how much? Okay, it is plus in charge, plus 1, whereas electron mass is considered as negligible. Okay, and its charge is how much? Okay, minus 1. Okay, we know it that electron is always in a minus and proton will be in a plus. It seems highly like that an atom was composed of a proton and electron. Okay, so from this we can estimate that atoms are composed of what? Okay, proton and electron mutually balancing their charge. Okay, they are mutually what? Okay, balancing their charge. Okay, if we take electron minus, then proton will be plus. Okay, so you can see that plus and minus will be neutralized. Okay, and they will balance its charge. Okay, so this way atom will balance its charge, okay, by their charges. Okay, so it also appeared that a proton were in the interior of an atom. Proton which are there, which is where? Okay, it is interior of the atom. Okay, it will be interior of the atom, whereas electrons could easily pillate off but not a proton. Okay, now the big question was, what sort of a structure did this particle of an atom form? We will find the answer by the question below. Okay, now the second question arises is how the atom is formed. This particle are there, but the structure of that is which proportion? Okay, so now we have concluded that there is a presence of proton, electron. Okay, proton is interior. Okay, so from this we can justify, but how the particle are arranged, okay, that we will study, okay, one by one, okay, through the structure of an atom. Through the structure of an atom, we will study this. The structure of an atom. We have run Dalton's atomic theory in chapter 3. In chapter 3, we have already run a Dalton's atomic theory, which suggests that the atom was indivisible and indestructible, okay, destructible as well as indivisible. But the discovery of a two fundamental particle, which is electron and proton, inside the atom, okay, lead to the failure of this aspect of a Dalton's atomic theory. Once again I am repeating what? Okay, Dalton's atomic theory in chapter 3, which suggests that what? Okay, atoms are indivisible as well as, okay, it is indestructible. Okay, but just now we have, okay, just now we have studied that discovery of a two fundamental particle are exist. Okay, two fundamental particle are exist in nature, okay, of an atom, which is electron and proton, okay, which are present inside the atom. Inside the atom, what are present? Okay, electron particle as well as proton particle are present. Okay, so this lead to failure of this aspect of Dalton's atomic theory. Okay, through which Dalton's atomic theory was what? Okay, failed. Why? Because fundamental particles are exist in atom, which we have studied just now. Okay, it was then considered necessary to know how electron and proton are arranged within an atom. Okay, if the electron and proton are present in the atom, then how they are arranged? Okay, that is curiosity. Okay, to us, that is one of the curiosity to any of them, that how they are arranged. Okay, that we will study just now. Okay, they are saying that atoms are present, but in atoms particles are there. Which are particles? Okay, electron, proton, just now we have studied, but their arrangement are of which type? Okay, that is also one of the curiosity. For explaining this, many scientists propose various atomic model. Okay, various atomic model are explained. Okay, J.J. Thomson was the first one to propose the model of a structure of atom. Okay, one by one, every scientist has given a different models. Okay, the first was J.J. Thomson. Okay, who has given a one of the structure of an atom. Okay, they have proposed a model. Okay, which we will study just now. Okay, so first is J.J. Thomson. Okay, now Thomson's model of an atom. Okay, through which Thomson has described that what is the structure of an atom and how the particle which are present they are arranged. Okay, they have proposed this Thomson model. In Thomson model, we will study the structure of atoms. Okay, now Thomson proposed the model of an atom to the similar to the Christmas pudding. Okay, Thomson proposed the model of an atom to similar. Okay, he has summarized a atom structure with whom, okay, Christmas pudding. Okay, the electron in the sphere of a positively charged were like a dry fruit. Okay, okay, in the Christmas pudding we can see that dry fruit is there. Okay, in place of that dry fruit, okay, in the atom of a in the structure of an atom, okay, he has taken electron in place of dry fruit. Okay, in the spherical Christmas pudding. Okay, so whole structure or spherical Christmas pudding are taken as what's, okay, that is one of the structure of an atom. In Christmas pudding there is a presence of dry fruit. Okay, so in atom there is a presence of electron in place of dry fruit. Okay, so this way he has compared, okay, a atom with whom, okay, Christmas pudding. Okay, so we can also think of a watermelon. Okay, the next he has summarized with a watermelon. Okay, in watermelon we can see that the positive charge in the atom is spread all over like the red edible part of a watermelon. Okay, if we compare an atom with a watermelon, okay, in watermelon we can see a red edible part are there. Okay, that red edible part are taken as a positive charge in the atom. Okay, if we compare it with the watermelon, in watermelon we can see that red edible part are there. Okay, that red edible part, okay, is one of what? Okay, that is positive charge in the atom. Okay, in the atom that proportion is the positive charge. Okay, while the electron are studied in the positive charge sphere, okay, like the seed in the watermelon. Okay, in watermelon we can see that black colored seeds are there. Okay, if we take a watermelon, in that we can see red black colored seeds are there. That black colored seeds are taken as an electron. Okay, if we compare it with the atom, in the atom, okay, black colored seeds, okay, here you can see that. Okay, if we compare a structure of atom with a watermelon, okay, here you can see that atom which we have taken a shape like a watermelon, in that red edible are taken as a positive charge, which you can see, and electron which are taken as a seeds in a watermelon. Okay, so from these he has compared a watermelon and atom, and through which they have given its justification and conclusion that a structure of atom is like a watermelon. Okay, Thomson proposed, okay, one by one he has given an atom consists of positively charged sphere. Okay, atom is consist of what? Okay, positively charged sphere, and electron are embedded in it, and electron which are present, okay, that are embedded in it. Now second he has given that the negative and positive charge are equal in magnitude. Okay, the negative and positive charge are what? Okay, equal in magnitude. So the atom as a whole is electrically neutral. Okay, so overall we can see that atoms are what? As a whole electrically neutral. Okay, so from this he has given that negative and positive charge are present, and both of them, okay, are equal in magnitude. Their magnitude are equal, but they are opposite with each other. Okay, so you can see that overall atoms are electrically neutral. Okay, so from this you can say that in atom there is a presence of positive charge as a proton and negative charge as a electron, and both positive and negative electron and proton, okay, both of them will neutralize each other. Okay, so on an average atom will be electrically what? Okay, they will be neutral. Okay, so although Thomson's model explained that atoms are electrically neutral, the result of the experiment carried out by other scientists could not be explained by this model, as we will see below. Okay, so this which statement? Okay, atoms are electrically neutral, that result is taken by whom? Of experiment carried out by the other scientists. Okay, second scientist has taken that statement, and on that statement he has prepared its experiment. Okay, by other scientists could not be explained by this model, as we will see below. Okay, so now the second is Rutherford model of an atom. Rutherford was interested in knowing how the electrons are arranged within an atom. Within an atom, how electrons are arranged. Okay. Rutherford designed an experiment for this. For this, he has designed what? Okay, he has designed experiment. In this experiment, fast moving alpha particle, okay, which we said as an alpha particle, fast moving alpha particle were made to fall on the thin gold field. Okay, in a thin gold field, okay, he has passed or incident a fast moving alpha particle. Okay, so this way he has performed his model and experiment. As you can see, he selected a golden field because he wanted a thin rare as possible. Okay, so he has taken a gold field. Okay, because gold field which is thin layer, okay, if it is possible, and gold field which is one of the thin layer. This gold field was about how many? Okay, 1000 atoms thick. Okay, that is 1000 atom thick. Okay, when alpha particle are incident at that time, what will be seen, that we will study further. Okay, now the second is what? Okay, alpha particle are doubly charged helium ion. Okay, alpha particle which we are taking, okay, it is what? Okay, it is doubly charged helium ion. That is doubly charged helium ion is there. Okay, that is alpha particle. Since they have a mass, how much? Okay, 4 unit. U means what? Okay, unit. Okay, they have a mass of 4 unit, and it is what? Okay, fastest moving alpha particle have a considerable amount of energy. Okay, it have a considerable amount of what? Okay, energy. And alpha particle is one of the fast moving okay, particle. Okay, so this way the alpha particle which is there, okay, it is what? Okay, it is doubly charged helium ion. It is one of the doubly charged helium ion. Okay, it is formed by doubly charged helium ion, which we say it is alpha particle. Okay, so it was expected that alpha particle would be diffracted by the subatomic particle in the gold atom. Okay, since the alpha particles were much heavier than the proton, okay, he did not expect to see a large deflection. Okay, so scientists has expected when we will incident alpha particle, at that time alpha particle will diffracted, okay, by the subatomic particle. But what happened? Okay, when alpha particle are incident at that time, he has seen that what? Okay, because of having alpha particle much heavier, okay, alpha particle are much heavier than proton, he did not expect to see a large reflection. Large reflection, okay, cannot be seen. Why? Because alpha particle are heavier as compared to a proton, due to which, okay, you will see that scientist has expected that he will see a large amount of diffraction, but okay, little bit amount of diffraction is only seen. Here you can see that, okay, some of them are diffracted, some of them are diffracted, and some of them are rebound. Okay, why? What happened? Because of presence of atoms of gold. Okay, now one by one we will study that only. But the alpha particle scattering experiment give a totally unexpected result. Okay, scientists has expected that what? Okay, scientists has expected that alpha particle will totally diffracted, but the alpha particle do not diffract large amount. Okay, little bit amount of diffraction is seen during the experiment. The following observation were made. Okay, first is what? Most of the fast moving alpha particle pass through straight through the gold field. Okay, most of them fast moving particle are passed straight through a gold field. Some of the alpha particle were diffracted by the fold by small angle. By small angle you can see that diffraction is seen. Okay, surprisingly, 1 out of every 12,000 particles appear to be rebound. Okay, what happened? Okay, certain particles are found to be rebound. Once again I am repeating what is that. Okay, in first, okay, first he has observed that most of the fast moving particle pass through a straight line through a gold field. Okay, in a gold field, okay, he has seen that most of the fast moving alpha particles are passed straightly. Barabar? Some of the alpha particles were diffracted. Okay, some of the amount are seen, they get diffracted, okay, by the fold by small angle, by little bit angle. Okay, he has shown some of the diffraction surprisingly. Okay, and last what happened? Surprisingly, one out of every 12,000 particle. Out of 12,000 particle, he has seen one get rebound. How many? Okay, one get rebound out of 12,000 particle which are inciding on a field. Okay, so one get rebound and rest of them are seen as a refraction, diffracted, as well as they are passed straightly. Okay, in the word of a Rutherford, okay, and he has given a conclusion that this result was almost incredible, as if you fire a 15 each cell at a piece of tissue paper and it come back and hit you. Okay, the experiment was like that. Okay, how much? Okay, he has unexpected result is seen. Now let us think of an activity in an open field to understand the implication of this experiment. Let a child stand in front of the wall with his eye closed. Okay, we have taken one child and we have closed his eyes. Okay, let him throw a stone at the wall from a distance. From a distance, we are what? Okay, we are giving a stone to the child and say that child to throw a stone, okay, to the wall. What will be seen? That he will hear a sound when each stone strike the wall. Okay, whenever he will throw a stone, at that time he will hear what? Okay, sound. Okay, if he repeat this 10 times, how many times? Okay, he is repeating 10 times, he will hear the sound 10 times. Okay, he will hear how much? Okay, 10 times he will hear. Why? Because child is throwing to the stone. Okay, when a stone strike to the wall, at that time it will produce sound, and that sound heard by a boy. But now the same way, the next is what? Okay, next case is this. But if a blindfolded child were to throw a stone at a bare wire fencing, okay, fencing wire, okay, what we have now, the second case in which, okay, child will throw a stone, okay, to the fencing wire, okay, to a fencing wall. Now in this case you will see that most of the stone will not hit the fencing. Okay, when a child is throwing a stone, at that time most of the stone will not hit the fencing and no sound will be here. And if the stone will not strike to the fencing, then he will not hear a sound. Okay, so this is because there are lot of gap. Why? Because there is a lot of gap in the fence which allow the stone to pass through it. Because of the gap in the fence, okay, fencing which we are seeing only, okay, the wall which have a fencing, okay, and there is a lot of gap between two fencing wire, and from the gap between two fencing wire, stone will be passed, due to which a sound will not be heard by a child. And when it strike to the fence, at that time he will hear. Okay, but most probably most of the stone will not hit the fencing, because of which child will not hear a sound. Okay, so this way he has explained. Following our similar reason, Rutherford concluded. Now the conclusion is that most of the space inside the atom is empty. Most of the space inside the atom are what? Okay, they are empty, because most of the alpha particle pass through the gold field without getting diffracted. Without getting diffracted, okay, what? Okay, most of the alpha particle will pass through the gold field. Okay, so just now we have studied that scientists do not get a proper amount of result. Why? Because he was estimated that alpha particle will diffract maximally, but in an experiment Rutherford has observed that there is not a maximum amount of diffraction, little bit amount of diffraction is seen. Okay, so he has concluded that conclusion given by him that most of the space inside the atom are empty. Okay, in atom most of the space are empty, due to which most of the alpha particle will pass through the gold field without getting diffracted. Very few particles were diffracted from their path, and few of them are diffracted, indicating that the positive charge of an atom occupy very little space and positive charge are very little space. Okay. Now, a very small fraction of alpha particle were diffracted by 180 degree. Okay, by a 180 degree, okay, very small fraction are there of a alpha particle which will be seen as a diffracted by angle how much? Okay, 180, indicating that all positive charge and mass of the gold atom were concentrated in a very small volume within the atom. Okay, from the data you also calculated that radius of the nucleus is about 10 raised to 5 times less than the radius of an atom. Okay, nucleus radius is how much? Okay, 10 raised to 5 times less as compared to the radius of an atom. Okay. Now the next is, on the basis of his experiment, Rutherford put forward the nuclear model of an atom which had the following features. Okay, these are some of the features. There is a positively charged center in the atom called nucleus. Okay, there is a presence of a positive charge center which is said to be what? Okay, it is said to be nucleus. Nearly all the mass of an atom reside in the nucleus. Okay, most of them are what? Okay, mass of an atom are reside as a nucleus. Okay, and the second is the electron revolve around the nucleus in well defined orbit. By a well defined orbit, electron revolve around the nucleus, and the size of the nucleus is very small as compared to the size of the atom. And if we compare a size of a nucleus, okay, that nucleus is inside the atom. Okay, so but obvious that its size will be what? Okay, small as compared to the size of the atom, because we know that nucleus is inside the atom. Okay, so but obvious that atom size will be greater as compared to the size of a nucleus. Now the drawbacks of the Rutherford model of a atom: the orbital revolution of a electron is not expected to be stable. Okay, it will continuously revolve. Okay, electron will revolve orbit continuously, so you can see that it is not stable. Any particle in a circular orbit will undergo acceleration, but obvious that particle will if is going circular orbit, they will accelerate. Okay, during acceleration, charged particle will radiate energy, and if it is a charged particle, then what will be seen here? We can see that electron, which is a charged particle, it will continuously radiate energy during the revolution. Okay, so thus the revolving electron, here in this case only we are saying that revolving electron will lose energy during the revolution, and finally fall into the nucleus. What will be seen? Electron will revolve around the orbit, okay, due to which it will emit or lose energy, and at last it will fall into the nucleus. If this well so, the atom should be highly unstable. So atom should be what? Okay, highly unstable, and hence matter would not exist in the form that we know. Okay, so then it will not be seen that matter whichever seen. We know that atoms are quite stable, but here we can see that atoms are what? Okay, quite stable. But in this case, okay, you can see that energy is emitting, okay, and atoms should be highly unstable. Okay, so this is the drawback of a Rutherford model.
Model of an atom was one of the most widely accepted models all over the world for understanding the structure of the atom. However, several experiments performed by scientists to study the atomic structure showed astonishingly different results. They were contradicting the plum pudding model. This led many scientists all over the globe to reconsider the structure of an atom and study it again. Around the year 1911, a British physicist, Ernst Rutherford, carried out the famous gold foil experiment. He did this to understand the structure of an atom. The experiment was carried out by Rutherford along with Hans Geiger and Ernest Marsden. The experiment he performed was a breakthrough in the field of chemistry which helped him understand the structure of an atom in a more accurate manner. This is how the setup of his experiment looked like. As we can see here, he used a source of alpha particles locked in a lead container with a very small slit. This ensured that the alpha particles only came out through a small opening and traveled in a straight line. But why did he select alpha particles in the first place? Well, the alpha particles were having high energy and were heavier as well. So if we say the atom is like a pudding of positively charged particles with electrons embedded in it, then the particles will pass straight through it. This is obvious because the heavier particles will pierce through the lighter pudding structure of the atom and pass through it. This is what Rutherford thought. For this reason, their greater mass and energy compared to the protons made him choose alpha particles for the experiment. Next, he used a very thin gold foil on which the alpha particles would bombard. Why did he choose a gold foil? Well, a really thin gold foil was estimated to contain approximately 1000 atoms. Lesser the atoms, more convenient the experiment would be. Lastly, are we able to locate this circular band with a gap here? What could this be? Well, this is a screen. A fluorescent screen that would help us detect the radiation. That means the screen will glow or emit fluorescent light whenever alpha particles will hit it. So this is how the track of alpha particles can be traced. Now we're all set to understand how the experiment worked. The alpha particles were emitted from the element present in this box. These directly hit the gold foil. Now what should happen ideally? As we know, the Thomson's model suggested that an atom is a sphere of positive charge with negative electrons embedded inside it. That means it is expected that the alpha particles will pass right through the atoms and hit the detector straight. And why so? Because the mass of alpha particles is heavier than the mass of positive charges. That means they should directly hit the atom and move ahead through it. Only a very small deviation would probably be acceptable in this case. But is this what he observed? Not really. He was astonished to get unexpected results. What results did he get? He found that most of the fast-moving alpha particles passed straight through the foil and hit the detector. However, some particles got deflected by small angles. And lastly, to his astonishment, few alpha particles also rebounded. Now, how can this be possible? These three observations made Rutherford think that the plum pudding model is not really correct.